Alrighty, we are going to use our TI in order to find a percentile for a normal distribution. The normal distribution we are working with is the distribution of the sample means for the mean lifespan of tires. We have a manufacturer who's created a new tire, and the manufacturer claims that the mean design life of all of these new tires is 38,500 miles with a standard deviation of 2,500 miles. We want to take a sample of 5 tires and find the mean. And the question we are asking is, what mean would be unusually low? In other words, what mean lifespan for these sample tires would separate the lowest 5% of the mean lifespans from the rest, the upper 95%? That lowest 5% of sample means would be means that are unusually low. This mean or below is unusually low. Any mean above that is not unusually low. So we are going to go back to our distributions button. So second vars takes us to our distributions because we're dealing with a normal distribution. However, we are not finding a probability now. We are finding a percentile. A percentile is a data value that gives us a certain probability. So that is the inverse norm. Go ahead and go down to inverse norm. And here, the area that we are looking at is our percentile as a decimal. We are looking for the 5th percentile, the mean that separates the lowest 5% from all the rest. 5% as a decimal is 0.05. The mean for the sampling distribution, or the distribution of the sample means, is the same as the population mean. So the population mean, the mean lifespan for all of these tires, is 38,500 miles. Now, we need to find the standard deviation for this distribution of the sample means. We know the standard deviation for the population of all tires, that's 2,500. However, we are not looking for a percentile for an individual tire. We are looking for a percentile for a mean of 5 tires that we take as a sample. So we would take our population standard deviation and divide it by the square root of the sample size. We are taking 5 tires for our sample, so the standard error of the mean, the standard deviation of the sampling distribution of the means, is the population standard deviation divided by the square root of the sample size. Now, again, I like to put this in exactly into my calculator to avoid rounding error. If you wanted to, you could do this 2,500 divided by the square root of 5 on the main screen, and I think you get 1,118. That's important when it comes to sketching the normal distribution curve that can help you visualize what's going on. But you're going to wind up with an answer that's just a little bit off. All right, go ahead and paste that onto your main screen. Again, if your calculator doesn't prompt you, make sure your notes include how to set up these parentheses. Inverse norm, percentile as a decimal, population mean, and then whatever standard deviation you're dealing with. If you're looking for a percentile for a population, what is the data value that separates the lowest percent of all data values? Then you would just do the 2,500, the standard deviation for the population. If you are looking for a percentile for the sample means, what is the percentile, or what is the data value that separates the lowest 5% of sample means of a given size? Make sure we have population standard deviation divided by the square root of sample size. All right, go ahead and hit enter. And here is our data value, where our data is the mean of a sample of size 5. This data value, a mean of 36,660 miles for the lifespan of a sample of 5 tires, or lower, is unusually low because only 5% of the samples should have means that are 36,660 or lower. As always, if you have questions, let me know.